Okay, so I think we can start now, and more people will be joining as we continue. So, so let me welcome you once again. So, welcome everyone. So, today we have organized this session, and basically we are going to talk about a very fundamental aspect of data science, which is exploratory data analysis. So, now, what is exploratory data analysis, or data scientists like to call it EDA? So, it is basically that just actually there is a huge amount of data on the internet. Okay, so someone has to draw some useful insights from that data or from that raw data, and then present it to the world for the common people to understand. So that is one of the basic things that a data scientist does, and this process is known as exploratory data analysis, or a very basic part of data mining, you can say, that just to draw some useful insights from any raw data set. So there are some tools which we use in kind of performing this. So two of just a second, someone wants to join this. Okay, so let's continue. So two of this two of the very basic tools, they are Matplotlib and Seaborn. So we'll just quickly go through them, see how they work and what are their syntaxes, and then I'll quickly walk you through the actual let's say the actual roadmap of how it is done. So let's start. So yeah, so this is Matplotlib. So what is the basic idea of Matplotlib? It is to use Python to create 2D plots out of arrays. And just a small thing, that when I say 2D plots, so it is not actually just 2D plots. See, the thing is that as Matplotlib advanced, so we can now actually build 3D plots over and above 2D plots, and we'll be seeing them in a few minutes. So, and yes, since it is a plotting library, so you can use it to create all types of basic things like line chart, bar chart, pie chart, or anything of that sort. So if you want to import Matplotlib, or basically if you want to use Matplotlib, see, I when I say that it is a Python library, so I actually assume that all the people who are present here, they have. I am not demanding much, but I assume that they have some proficiency in Python, because most of the data analysis in the industry is done in Python only. So, and there are some more tools like R, SAS, and some more tools, but Python remains the topmost. So, I assume that you guys have some sort of familiarity with Python. So, yes. So, and if you have, then we all know that if we want to import a library to Python, then we use the import command like this. So import matplotlib.pyplot. See, pyplot is let's say a basic subsidiary of Matplotlib, and all the plotting is actually done by pyplot. So we import matplotlib.pyplot as PLT, and let's see a few examples now. So let's say you want to draw a straight line. So you will be needing two arrays, which will be your data points in x-axis and your data points in y-axis. So like we can see here that in the left side, in the code snippet part, so we have taken the x-axis, the data points in the x-axis to be 10, 20, 30, and 40. And the data points in the y-axis to be 20, 30, 40, and 50. So these are comma separated values, and like I said, these are delimited with a comma. So, and one more thing, that when you are plotting this, so one thing that you need to keep in mind is that the dimensions of the x and the y axis arrays should be the same. Like if there are, let's say, four components in the x axis data point, so there has to be corresponding four data points in the y axis too. This plotting tool isn't going to help you if let's say you have three data points or five data points in the y-axis while you have four in x. So yes, So then when you declare the arrays, then you have to use plt.plot, and then basically this plot takes two inputs. It is the array of x-axis and the array of y-axis. And then we use plt.title. So plt.title is used to give the title of this plot on the right hand side that we can see. So like we have set this title to first plot, and I think this image is a little distorted. Like it is written simple plot here, but if you write here the first plot, so it should reflect first plot over here. Okay, so when we'll use it, then it will come out to be first plot. Don't worry. And the we can set the y label, which is going to set the label of the y-axis, like we can see here the y-axis, and likewise we can also set it to be the x-axis, like we can see here. And then when we are done with all these, then finally we can use the command plt.show, and then we'll be able to see this plot. So let's give you a we'll be plotting these in a few minutes, so don't worry. So let's see for bar graph. So it is the same for the bar graph too. Like import matplotlib.pyplot, and then you will have to declare two arrays just as we did earlier. Like in the x part, you will have to declare the data points on the x-axis, and in the y part, you will have to declare the points in the y-axis. And then plt.bar, like in the earlier we used plt.plot x comma y, and likewise if we want to draw bar graph, then we are going to use plt.bar, and similarly it also takes two values x and y. So like we use the title there also, so we are again using the title. Like I gave the title here as bar chart, so the title here reflects as bar chart. And plt.legend, see when you are plotting a graph, some at some point or the other you might need a legend. So matplotlib also gives you the option to set it according to your convenience. So like when you declare plt.legend and give an input bar, so similarly it will reflect here. Like you can see the legend right here, and it is also the bar. And then we can use plt.show, and then it comes. So basically, when you have completed all the formalities, declared everything, and at the end you will have to use plt.show to actually get the chart out of your code. Okay, so let's see the same for scatter plot. See, and one more thing, that scatter plot is actually by far the most important tool that I have used, because when you are actually doing exploratory data analysis, so at multiple points of time you will need to find out correlation between two features. And when you have to find out the correlation, so at that point of time scatter plot actually helps a lot, because I think that some of you might be well versed in it. So especially the PhD people and the people who have actually some experience in research. So if we see the scatter plot of a, let's say, positive correlation, then it is a like a humongous number of data points going in the upward direction. If I get the time, I'll definitely show it to you. So similarly, as we did earlier, for to make a scatter plot too, we'll need to arrays, the data points in the x and the data points in y. And for scatter plot, we'll have to use plt.scatter x.y. Just a minute. Okay, so plt.scatter x.y, and like we are already well versed with the plt.title by now. So scatter chart, and like I already told you that how to use the legend. So we have also used the legend there, plt.legend a, and the same reflects it. And then at last, as I said, plt.show. And one more thing, that this is the last chart that we are going to discuss. Last basic charts. I mean, there are a lot types of chart in Matplotlib and Seaborn, but for the sake of convenience, I'll just be going through the basic ones today. So if you want me to have a session on the most advanced one, then I'll definitely have at a later stage of time. So see, if we want to draw pie chart now, like the charts we drew earlier, there we needed two axes, the x-axis and the y-axis, but it is not the case with pie chart. So in pie chart, you only need one array, which we have taken as x to be here, 1, 2, 3, 4. So we have taken 4 data points, 1, 2, 3, 4, and one very interesting feature of this pie chart that Matplotlib provides is the let's say explode factor. So if you want a certain element to be standing out from the rest of the elements in pie chart, from the rest of the elements in pie chart, then you can use the explode option. So like here we have declared a tuple in Python with the element 0.1000. So this actually means, like I have also given the comment here, this means that you want the first element, like the one, this element, to stand out from the rest of them, like we can see here in this chart. Okay, so when we use this plt.py, so like we have used plt.scatter earlier. So likewise, we are going to use plt.py in this case. So plt.py, we give the input, the array that we want to draw, make a chart of, and then after comma, we write explode equals this tuple that we have declared right here. So when we do this, this part that you have declared to be non-zero stands out from the rest. Okay, and this is plt.title pie chart as we already saw, and then finally plt.show. Now, initially I told you that this Matplotlib is used to draw 2D plots, but as I said that as Matplotlib went into the further stages of its development, then a need of 3D plot was also needed. And basically what Matplotlib does is that I mean, this is not an ingenious idea. This is a very old idea, but it was the first to implement this. Okay, so see, like you can see the three planes here. So Matplotlib first, let's say, draws three separate planes like the xy plane, yz plane, and the zx plane, and it plots the data points on them, and then it combines them to give you this 3D plot like we can see here. So to get a 3D plot, obviously we need three arrays with three data points. So like we have declared a 1 2 3 4 5, the square of it and the cube of it. I mean, this is just a dummy data set, so you can take anything you want. And then we use a separate thing. We have not used this till now, but now we are using it. See, we are declaring a figure, let's say element. So we declare a figure element, fig equals plt.figure. So like the earlier charts that we discussed, like this plt.py. So once you write this code, you can only get this chart once. I mean, if you want to get this chart again, then you'll have to write or copy this piece of code again. But if you want to reuse the same chart in different points of time in your Python notebook or anything, then you can use this figure class. So we have declared this figure equals plt.figure, and then we have declared the axis to be plt.axis projection equals 3D. By this, we declare that we are going to make a 3D plot, and then finally ax, which the axis we chose, dot plot 3D, and the inputs we can give z, y, and x. So by this, we can get a 3D plot. So this was all about Matplotlib, and like I gave you the idea of all these plots in Matplotlib, so I'm not going to do that again for Seaborn. So basically, I'm leaving it as a kind of assignment for you to complete, and I'll just give you a brief intro of what Seaborn is. So first Matplotlib came, and then people actually thought that the visualizations provided by Matplotlib, either they were not let's say professional enough, or they did not provide enough design elements. So due to that, Seaborn was born, and that sounds different. Seaborn was born, but anyway, Seaborn was born, and Seaborn is a library which is built on top of Matplotlib. So the essential core of Seaborn is Matplotlib. So it is also a Python library, like we saw earlier. And if we want to use C1, then we'll use import. I don't know why I wrote port again. So it's just import Seaborn as SNS. Okay, I'll just quickly change it. I don't think. Okay, so import C1, just ignore this port. Import Seaborn as SNS. Okay. So now we are done with the theoretical part, and let's take a look at how the EDA is actually done. So anyone has any questions at this point of time that I can answer before moving to the next part? Anyone? Okay, I think we are good to go. Nice. Okay, so now let's just see that how we actually do an exploratory data analysis. So let me share that part. So is my screen visible? Anyone?
Yes, it is visible.
Okay, sure. Thank you. So now let's dive into the practical part. So we are going to take a data set that deals with the suicide cases in India from 2001 to 2012. Okay, and let's see that what we can make out of this data set. And I'm going to quickly show you the data set too. Okay, so now we are going to use Numpy and Pandas. See, these are two very crucial libraries in data science, as you can see it in equivalence of a spreadsheet. Like you take a spreadsheet, so if you need a spreadsheet in your Python notebook, you can easily use Pandas and Numpy. And the calculation features that they provide, they are of paramount importance. So they are the most used libraries in the field of data science. So just as NP, as PD. Yes. So now if you want to read the data set, so we are going to read the data set using Pandas. So I'll just quickly show you how it is done. So yes, we use this command that suicide data. See, we are going to store our data set into this variable, which is suicide data. Okay. So we write suicide data equals PD. PD, we just imported pandas. PD dot read CSV, use the read CSV command, and then inside it, the name of the data set. So we have successfully imported our data set. Now, if we want to see the data set, we are going to use, just write the name, suicide data, and this is our data. So like we can see that the data set has columns of state here, type code, type, gender, age group, and total. So the state obviously stands for the state in which the suicide took place. We can see the year from here, that in which year the suicide took place. The type code basically tells us that what was the let's say a short intro of what was the cause of the suicide. Like here it's the causes. Here it was something about the social status, like the suicide happened due to the social status, and then there's a column of type. So with this, we can actually see that what were the types due to which the suicide took place, like illness, bankruptcy, physical abuse, and in social status, we can see married, divorced, separated. So what was the social status of the person who committed the suicide? Gender, obviously, male or female. Age group, we can see the age group in which the person was when he committed suicide. So this was a quick intro of how the columns of this data set look. So now, see, we can see that there are quite a few repetitions in the state, like Andaman and Nicobar Island, and here we have skip the data because, like we can see, there are 237,518 rows in our data set. So it isn't humanly possible to examine each one of them. So if we, let's say, if we want to get a list of what are the different states, what are the different unique states that are consisted in this data set. So we use this command. suicide data, and inside square brackets we write state. State is the basically we write the name of the column of which we want to get the unique data from, dot unique. And don't worry, I'll be sharing this Python notebook with all of you, so you can also write this at home. So see, when we use this command, we got all the unique states name in which their suicides were there. Andaman and Nicobar Island, Andhra Pradesh, Arunachal, Assam, and you get the idea, right? So let's test this on a separate column. So let's say we test this on type code, that how many unique type code are there in this data set. So we can do this. Let's see what is type code. Okay. So suicide data type code dot unique. So these are the different type codes that our data set has, which is causes, educational status, means adopted, professional profile, and likewise all of these. Okay, so now we have got a feel of that how a data set actually looks. Okay, so now we are ready to proceed further. So let's check that if our data has any missing values, because when you actually get down to doing all the tinkering with your data set, the missing values actually have the capacity to harass you a lot, because this missing value causes problems in calculations and the other things. So let's check that whether we have any missing values in our data set or not. So for that, we use this import missing no as msno, and msno dot bar, and inside the brackets we use our data, which we used suicide data, like we used suicide data, so we put inside the brackets suicide data. So like we can see here in the chart that in all the columns we have an equal number of elements, which are 2,37,519. So from this, we get to know that there are at least no missing values. So we can proceed peacefully. Okay, so you get the idea, right? So till here, anyone has any questions? So are all of you with me? Can you just type in the comments? Are you with me? Yes or no? Yes, perfect.
Like if there is missing data, then what should be done? Like what should be the
Okay.
basic approach?
Okay, so see, wherever there is a missing data, so intuitively, what we can do is that let's say there is a column, and which, okay, so I'll give you a short idea with this. Sorry. Yeah. Okay, so let's say that you have an array which is like this: 1, 2, 3. Here is the missing data: 4, 5, and 6. Okay, so now if you try to do the calculations in this, so the calculation might be stuck somewhere. So like here is the missing data point, like you can see here. Okay, so if you want to fill this missing data, so there are actually many approaches. Okay, so the most basic approach is that take the median of all the other data points which are available, median, or let's say take the average of these data points. Okay, so let's say that we take what are the data points: 1, 2, 3, 4, 5, 6. Okay. So what is the average of this data point? It is 7 by 2 or 3.5. Okay. So we can fill 3.5 in this missing data point. Okay. So it is just for the sake of calculations, and there is not much that we can do about it. But this is the industry standard, and all the books also recommend the same. So is that clear?
Yes, but
Perfect.
if there are a lot of missing values, then this will be problematic, right?
Exactly, this will be problematic. So if there are a lot of missing data values, then what we do is that whatever data we have, we fragment it. Like let's say, I'll give you the example here too. Like we have the missing value here, and let's say we have a second missing value here. Okay, so what we can do in this case is that let's say we have this missing, in this missing value, we can fit the average of all the values above it, like we here 1, 2, 3. So in we can take the average of 1, 2, 3, and we can put it in this missing value. So we can take this as 2, and we can do the same in this one. So in this one, all the data points before it is 1, 2, 3, 2, 4, 5, 6. So whatever is the average of this, I guess. Uh, can someone calculate it for me? So you get the idea, right? So here we take the average of 1, 2, 3, 2, 4, 5, 6. So anything, let's say it is y. So we can put y here. Is that clear?
Okay.
Yeah, perfect. So like I said, it is not a very good way, but it is the only way that is available. Okay, so let's continue. So we don't have any missing data points, so we can proceed further. So just give me a second. Yes. So the next thing that we are going to do is this. So what I have done here is that I have taken this suicide data, the data set we had, and we have taken group by state total dot sum. So in GRP, in the variable GRP, we have stored all the suicides of all the different states. Like we have Andaman Nicobar, we have various repetitions of Andaman and Nicobar Island. So what this group by sum does is that it takes the sum of how many times the name Andaman and Nicobar Islands has occurred. And so because of this, we can see that we can see the total suicide count of the different states. So total suicides, we use a data frame. So there is a concept of data frame in Pandas, which is the same as spreadsheet. So in Pandas, when you enter the data, it is in the raw form, and if you actually want to convert it into a, let's say, spreadsheet type of data, we use data frame here. Okay, so we have done some basic formatting here, like sorting values, and we have sorted the total in a descending order. So to sort in descending order, we use ascending equals false. So by default, there is no descending order. So we use ascending equals false. So this says that it is in the normal or the descending order. Okay. So total suicides, what we actually do is that see, this is the concept of slicing in Python. So what slicing is that, like we saw that we have different numbers of columns in our data set. So what this does is that it ignores the first and the second columns, and it does its calculations of thing from the third column itself. So this was not supposed to return anything. So yeah. So in, like we have saw that in total suicides, we have stored the total suicide count of all the states. And now let's see it that what we have actually done. So yeah, this is the output that we have got. So like I said that we are using a descending order. So the highest state count is in Maharashtra, and a total of this, and likewise we can get a total number of suicides in different states. Okay, so now we have this data in text form. So now let's try to make it slightly graphical so that a majority of our users can understand it. So we are going to use this command. So like I already said, import matplotlib as PLT, import Seaborn as SNS, and I already talked about this fig instance that you can use, and AX stands for axis. I already told you. I forgot to tell you about this subplot. So if you want to plot more than one graphs in a single plot, so in that case, we can use subplots. And fig size is for size of the figure that you want to have. Like depending on different projects, you might desire different dimensions of a plot. So you can use this fig size for the same. And let's say we take a variable g, and we want to have a bar plot, like the bar graph in Matplotlib. So we are going to use this time in Seaborn. I already told that we are going to see in the notebook. So yeah, in the x-axis we are going to take the state, and in y-axis we are going to take the total number of suicides in that particular states, and the data, the total suicide. The total suicide list that we generated earlier, like this one, total suicides. So data, we are going to take this, and this is for the axis. So I won't go into this at the moment, but you get the idea, right? So yeah, this is the plot that we have generated from this. Okay, so this, from this we get this. Okay, so I think that's beautiful enough. So let's continue. So now let's try to make a pie chart. So let's take a pie chart of how many victims were males and how many victims were females. So for that, we are going to use this. So we take a variable count, and in count, what we do is that we take the suicide data and we take the gender column of it. We take the gender column of the spreadsheet that we had, and we do dot value counts dot sort index. Okay. So what this does is basically it counts that how many suicides, that how many victims were male and how many victims were female. Okay, and so we get this data in a variable counts, and then when we want to plot a pie chart, so we use this counts. We take the this variable dot plot kind equals pie title, the title of the graph, gender count, and fig size. Like I already said, this is completely up to you. So plt.legend, and when you leave it to plt.legend, so it chooses the legend by itself. It makes the legend by itself, and then at last plt.show. So when we run it, so we get this. So like we have printed counts here. So we get female this number and male this number. So these much victims are female and these were much were male. So I think that's quite similar. So it can't be said that which category committed no suicide, but you get the idea. And like I said that the what we say, the legend, we left the legend category to be blank, so it generated the legend by itself. So male female. Okay. So now let's take it a bit further, and let's see that, let's make a pie chart out of what were the different type codes. Like we already saw that social status and all of that. So for that we use this suicide data. We took the column type code and dot value count dot plot kind equals pi. Okay. So see, the majority of the suicides reported, the data considered the type code to be causes. Then the, let's say, title of the graph, it was type code, means adopted, professional profile, education status, and social status. Okay, so let's take it a bit further, and let's do the same with age group. Okay, so we get this data, right? So 0 to 100, I guess that they didn't have the exact figures, so that in which category it lay in. So it gave 0 to 100 plus. So I guess every other categories automatically comes into it. But let's say that this was the non-organized data. So like you can see that as far I can see that all the ones are pretty equal, and till you don't get a numerical value out of this pie chart, so till then you won't be able to distinguish that which one is more. But visually, if you want to do it, then definitely you can try it. I mean, yes, you can take it up as an assignment. Okay, so now we are storing the different variables in let's say cause, education status, means adopted, this professional profile, and the social status. So just have a look at the code once, and you'll get to know that what are we going to use these codes for. So I won't get into the very much details because I think we are quite short in time. So I'll share this with you, and you can definitely get an idea. And if you don't understand anything, then you can always get back to me. So let's generate a new kind of plot. Yes, so this plot basically tells us that what were the major causes by which the suicides actually occurred. Okay, So like we stored the causes data in the this cause variable, as we can see here, and cause equals suicide data, and we took type code equals causes. So like I said, if you don't get anything, you can always ask to me at any later point of time. And then we have made this function. So this function actually helps us to make the plot. So like if I wanted to make let's say 10 different plots of the same design, I I'd had to write this code 10 different times. So what I did, I made a function out of it, and now I can easily reuse. The function name is plot type, and we use a plot type. Plot type, the data which you want to make a plot of, the title of the graph, like we can see this, and the cause, obviously. So, like you can see here, we get a nice plot of the different reasons why the person committed suicide. And from this data, I think it is quite obvious that the majority of the victims, they were having problems in family, or family problems, like we can see. Okay, and which is followed by causes not known. I guess the government is too lazy to collect this data. And by the way, this data set is quite reliable, as it is available on the Government of India website. So this is not a bogus data, and the data which we are working on is pretty authentic. And other prolonged illness, insanity, mental illness, love affairs, and you get the idea. Okay, so let's take it a little bit further. So now let's see the education status of the people, and yeah, we get this data. So this is the suicide by education status. So from this we can see that the least number of suicides that happened, the victims belong to the postgraduate and the above category, and the most suicides they had by the primary education, who had the primary education. So we can take a basic inference from this, that the more the person is educated, the less likely he or she is he or she is less likely to commit suicide. Okay, so I said we can take a basic inference, because we cannot take it as an absolute truth, because a lot of statistics goes in behind actually determining that is this inference actually true or not. The second year students who have just gone into second year, they are going to study this in a course, statistical programming. I believe that you're going to take this course this semester itself. So you'll take this course in statistical, you'll get to study these things in that course. So it is a good course, and you'll study about p-value and these things. So the use of those things are here. So let's see something else, that what were the means adopted by the victims. Okay, so here we see that a disproportionate number of victims, they died by hanging. And by the way, I'm using the same function and again, the function that we made here, which is plot type. Okay, so in plot type, plot type function has three parameters: data, title, and xlab. Xlab is basically the same as what you want to see, or the data. Like I want to see the means adopted here, so you can put means adopted here. Okay, so seems good. So and which is followed by consuming insecticides, by consuming other poisons, and the rest of the things are obvious by themselves. Okay, so now let's run the same function and see that what was the professional profile of the victims. So we see that others, please specify. I mean, simpler incompetence on the side of the government of India, so it can't be blamed. So the other, we can see that the victims were majorly housewives, followed by the people employed in the farming and agriculture industry, and followed by service private sector, and which is quite similar to the unemployed population. Then students, professional activities, and the rest of the things. Okay, so now let's do the similar analysis and see that what was the social profile of these people. So the most number of people who committed suicides were married. The next was they never married, followed by widower, separated, and divorcee. So yes. Okay, so now let's see that how many people actually fall into the different age groups. Like the earlier charts we made, I think it is here. Yeah, this chart. So in this, I said that we are not actually able to determine that which one is bigger because these look quite similar. So now let's see the numerical aspect of this, that how much people actually fall into the different age group. Okay. So for that we have a function AGRP and suicide data, the actual spreadsheet that we have. We use the function instance group by. We say age group, like we want to group the data from the column of age group, and then we want to store it in a column called total and then sum it up. Okay, so it is the same thing. So let's run it. So we see that the majority of the people, they fall into the category of 15 to 29. Okay, so and 60 plus is this, 45 to 59 is this, and so on. You get the idea, right? Okay. Okay. So now let's draw a bar graph out of this data. So let's see. Yeah. So from this, we can see that a majority of the people, they were in the 15 to 29 years of range. So they were quite young, and sadly they committed suicide for the reasons that we have seen above. That what they did and what were the means adopted, why they did. Okay. So yeah, and one more thing, that these categories that we have got here in the age group, they are not the same as the categories they were in this pie chart. Okay, so in the pie chart they're not exactly same, or majority they are quite the same. Like in the 0 to 100 category, we have removed that category because that was quite problematic. So moving forward, let's see that how the data looked like if we want to analyze the suicide rates of different states in different years. So for that we are using this, and when we do this we are going to get this. Okay, so like I said, we are running quite short of time, or else I would love to walk you through this piece of code, but I think that we'll have to rush this up. And I'll definitely share this notebook with you, so you can always have the time to analyze it. Okay, so the data looks like this. Okay, so moving a little forward, let's draw a graph out of this. So we are using a line plot here, like I said, SNS stands for Seaborn, and line plot year, number of suicides, and the data is yearly. So we get this beautiful line plot, and okay. So now let's see the data state-wise. Okay, that how the data actually looks for states. So what we have did is that we have taken three states, three random states. You can take anyone. In the state one, we are going to analyze Maharashtra. In state two, we are going to analyze West Bengal, and in state three, we are going to analyze Tamil Nadu. Okay. So what we are doing here is that like the suicide data is the actually spreadsheet, and we are going to take the state instance of it, and see, like I already said, that we have taken the spreadsheet suicide data in the square brackets. We wanted to have Maharashtra. Okay, so we have to, we actually need all the data of Maharashtra. So what we do is that inside it also we write suicide data once again, state Maharashtra. So this stores all the data of Maharashtra in state one. So let's run this. And so likewise, we can analyze the data of Maharashtra by using the state one variable. We have seen it here. So for Maharashtra, you can see the year, type code, gender, age group, profile. So and likewise, if you want to see of West Bengal, then just write state 2 and run this code. So you will get it of West Bengal. Okay. So yeah. Okay. So I think just give me a minute. Just a minute. Okay. Let's continue. So just wait for a second. Okay, so now let's plot the data for different states going by the age data. So I think I'm quite lost. So for that we use this function, which is plot for state by age. Okay, and let's say we enter the state one attribute in this, and the state one actually is of Maharashtra, like we already saw. So if we run it, we get the data of this. So this data basically analyzes the different victims of suicide by ages for a given state. Okay, so like for state one, we had Maharashtra, and if you want to analyze of Tamil Nadu, so just change 1/3. So you'll get the same for Tamil Nadu also. So this is for Tamil Nadu. Okay, so moving forward. Now, let's see that what is the social issue causing suicide. So, for that, just a second. So, like we already saw that we are going to segregate this time from gender. So, if we see married, so out of all the people who committed suicide and they were married, a majority of them were male. Disproportionate number of them were male, like we can see here. And for the never married type also it's male. For divorcee, I guess it is quite equal. So we use this piece of code for the same. So you can just analyze this, and then we can discuss it at a later point of time. Okay, and likewise, we are going to analyze the education status and the profession of all the people who were the victims. So this is the social status, and we are again going to segregate it from a gender point of view. So like we can see that if then we consider the no education category, then also the majority of the cases were for the male population, and I'm surprised to see that in no cases the female population is more than male. So I don't know the reason for that. If anyone knows, then please go ahead. So now let's see that what is the profession of the people who committed suicide. So likewise, we are going to use the same piece of code, just change it for profession. And okay, yes, I got one, but I think it is a housewife. So I guess all the housewives are female. So yeah, I mean this is the only one where the female population is more than male. So yeah, it is what it is. So okay, so after all of this, let's see that uh, what is what are the conclusions that we can draw out of these. Okay, so just give me a second for this. So the conclusions that we can see out of the exploratory data analysis that we did just now is that males tend to commit more suicides compared to females in India, as all these charts above suggest. As in every one of them, the male population is higher. So yeah, the first point is quite obvious after looking at the charts. The highest number of suicide cases occur in Maharashtra, West Bengal, and Tamil Nadu. So we got this data somewhere around here, I believe. Yeah. So so above there was a more cleaner version. Oh, I don't know where it is. Yeah, here it is. So, Maharashtra, West Bengal, and Tamil Nadu. So, the most suicide cases were reported in Maharashtra, followed by West Bengal, and then followed by Tamil Nadu. So, yes, this is also quite obvious after looking at the charts. Male might commit more suicide compared to females in the future if this trend continues, which is an extension of the first point. People who commit suicide are mostly married, uh, like we can see from this, I believe. Where it is. Yeah, people who commit the most suicides, they are married, and likewise we can see they are farmers and housewives, and the most people are sadly youngsters of 15 to 29 years of age, followed by the middle age, which is 30 to 44. So yes, I believe that we have successfully completed the exploratory data analysis of this data set, and now, if anyone has any questions, then please feel free to ask anyone. Any questions regarding how the things were done, or any questions in general that how we perform the analysis, or if anyone had some problems in Python. Okay, no.
Hello,
Yes, who's this?
this is
Uh,
Dhruv.
yeah, please.
So I had a doubt that are there any kind of thumb rules of what kind of plots to use to visualize data better?
Certainly not, because see, exploratory data analysis is basically a reflection of how loose can you let your creativity to be. So, because just if when you actually take a data set and open a notebook that I'll perform AD on this data set today, so basically it's all about that. What different permutations and combinations of the charts and plots you can use, and how you want to use them. So it's all up to you. There is no thumb rule for this.
Okay, got it.
Yeah.
And one more question. It is actually a follow-up with respect to the earlier discussion. That was, if we have some missing data points,
Mhm.
then what should we do? So you had mentioned that we can take an average and all.
Mhm.
But can't we just totally omit that data entry which has missing data?
Yes, definitely you can do it. See, like I already said, that these things do not have any hard and fast rules. Especially the industry standard is this, that you can do whatever you wish. I mean, not exactly whatever you wish, or more like whatever your boss wishes or your team wishes. So there are multiple ways to analyze the same data set, and outputs also may be different for different things that you might want to find. So I only mentioned one of the things, that you can take average, you can take medians, and the point that you stated, that we can completely omit that data point. That is also quite fine. I mean, I don't find any problem with it. You can certainly do that.
Okay, all right.
Yeah, sure. So anyone else? Well, okay then. So I believe that you guys enjoyed it. So do you think that this session was beneficial for you, or you learned something? And just can you just reply in the chat boxes if you don't want to speak? It's perfect. Yeah, Anant, I guess that you want to speak something. Yes, I can say. So please, if you want.